This PowerPoint will help you with inequalities. We use inequalities to indicate that two quantities are unequal. These are the four symbols we use when we are dealing with inequalities. One thing to keep in mind, when you have something that is greater than or equal to, or less than or equal to, you have to remember to put the bar underneath both of those symbols. Here are some inequality rules we need to know. For the most part, we treat inequalities just like we would an equation. The only difference is equations have the equal sign, and inequalities have the greater than sign, less than sign, greater than or equal to, less than or equal to, just like we talked about in the previous slide. Adding or subtracting the same number on both sides of an inequality does not change the solution, just like we do in an equation. In this example, when we have x plus 2 is greater than 4, subtracting 2 from the left side to the right side does not change this inequality. We will still have x is greater than 4 minus 2, which is 2. The next rule is multiplying or dividing by the same positive number does not change the solution once again. So in this example, if we were to divide the left side by 5 and the right side by 5, because whatever we do to the left, we have to do to the right, just like in an equation, our 5s would divide to 1, and we would be left with x is less than 10 divided by 5, which is 2. We can see that multiplying or dividing by the same positive number does not change the solution, just like it doesn't in an equation. We learned that multiplying or dividing by the same positive number doesn't change the solution. However, when we multiply or divide by the same negative number, our solution will change. You must always remember to reverse the inequality sign when you're dividing or multiplying by the same negative number. If you look at our example below, negative 2x is less than 4. If we divide both of the sides by a negative 2, our answer and our sign will flip. So our answer will become x is greater than negative 2. Remember to always reverse the inequality sign when you're dividing or multiplying by the same negative number. Next, we're going to look at solving an inequality that's a little bit more challenging. Our same rules apply as they would for our equation. We still want to isolate our variable x. So in the following problem, our first step would be to distribute the 3 to both pieces. When we do this, we get 6x minus 27 is less than 9. Now, our next step will be to add 27 to both sides. When we add or subtract a number, we know that the sign does not change because of our rules of inequalities. Adding 27 to the other side gives us 6x is less than 36. Our last step to isolate our variable x will be to divide both sides by 6. When we have 6x less than 36, dividing by 6 on the left side cancels to 1. When we divide 36 by 6, we get 6. Now, since we divided by a positive number, we know our rules say that our sign will not change, so x will still be less than 6. Now we're going to look at x less than 6 in a little bit of a different way. We're going to look at it using our interval notation. Interval notation is a way we can write our inequalities to show an answer in a simpler form. A couple things to remember. When we have an inequality with a greater than or equal to, we will always use brackets. Our brackets will always be used also with when we have less than or equal to. If there is just a greater than or less than symbol, we will always use our parentheses. Another thing to remember, if a number is less than 6 in our solution up here, we are going to be able to use our infinities. We will have a negative infinity or a positive infinity. Whenever we have infinities, we also want to remember that they always come with parentheses. So how we would write x is less than 6 in our interval notation would be parenthesis, negative infinity, all the way to 6, other parenthesis, because we just have a less than symbol in it. We know that it goes off to negative infinity because x is less than our number, so that is saying it is going off into negative infinity. As we know, we always want to use parentheses with positive and negative infinity. Our answers below are written in interval notation. If x is less than 6, we know that x will be going off into negative infinity, and then we know there's 6. We will have a parenthesis around both pieces because it is less than and because we have an infinity. Our next problem, x is greater than or equal to 12, we know we will have a positive infinity because it is greater than a number, and we know that our infinities always have parentheses, and we know we always have 12 because that is our answer, and 12 needs a bracket because it is greater than or equal to. Our last example, -5 is less than x. We know that -5 will need a parenthesis because it is less than our x. Also, we know that since x is greater than -5, it will be going off into positive infinity. Whenever we have infinities, we know we must use a parenthesis. These are just some examples of how we can write our interval notation. We will now solve an inequality. Our first step to isolate our variable x will be to add 8 to both sides, leaving us with -12x is less than or equal to 16 plus 8, which is 24. Our next step will be to divide -12 from both sides. The -12's on the left will divide to 1, and we will be left with an x is less than or equal to 24 divided by -12, which we know is -2. Now remember, we divided by a negative number. So our last step we know will have to be to change our sign. So our final answer would be x is greater than or equal to a -2. Now, the next part of our problem says we need to write our answer in interval notation. To write our answer into interval notation, we know we are going to have a -2 in our answer. We also know we are going to need either a positive or negative infinity. Since x is greater than our number, we know we're going to use a positive infinity. Infinities always come with parentheses, and we know since our equation says greater than or equal to, our -2 will have a bracket. And this will be our final answer written in interval notation. Next, we're going to go over some vocabulary terms. Our first vocabulary word we are going to go over is union. Union is used when we have an or in our inequalities. If we want to show how this is done with the following inequalities on top, our first thing we would do is we would write 2, 3, 4, 5, and if we want the union, a union is denoted by that symbol. Our next word, intersection, is denoted by this symbol and is used when we see and in our equation. So for the following examples, 2, 3, 4, 5, if we had an intersection between these two, we would put the intersection symbol in between them. Some examples of interval notation using and or are below. Our first example says x is less than -4 and is greater than -7. We can also write this as, when we write it in this form, our x is in between our -7 and our -4. If this happens, we know it will not be going off into infinity or negative infinity, so it can be written as -7, -4. We use parentheses because we just have less than symbols. There are no less than or equal to. Our next example, x is greater than or equal to -1, and x is less than or equal to -3. We know our x is going to be greater than everything bigger than -1, so it'll go off into positive infinity. If x is less than everything of -3, we know it'll go off into negative infinity. Our -1 and -3 have parentheses because we have less than or equal to and greater than or equal to symbols. With these symbols, we know that our numbers are going to need brackets. Our infinities will always have parentheses, and our last thing to look at for our interval notation is our word or. When we see the word or, we know that it is automatically a union. With a union, we know we need to use this symbol, and we will put that right in between our equations. So this will be our final answer. The last inequality we're going to talk about is the double inequality. The double inequality looks like the following example. It gets its name by having two inequality symbols inside the inequality. To solve this, we are going to break it into two separate inequalities. We are going to look at the first one with a -3, having the first one this way. The next one we will look at is the 2x plus 5 is less than 7. These are the two inequalities we are going to break up for this example. And then once we break those up, we will put it together into interval notation just like all our other inequalities. We will solve these the same way as single inequalities. We will just have two potential answers.